One thing that we can see here in the machine learning life cycle is that there are some arrows that point from model evaluation to feature engineering to data collection and preparation and to goal definition. We can call these as feedback loops. Let's say we evaluate our model on and we feel that including more features may improve the performance of our model. We need to go back to the feature engineering step, and let's say we now included certain features that we earlier thought were of not much importance. Now we again continued following the pipeline and build our model and evaluate it to see if it has improved its performance. It can also happen that we may need to go to the data collection and preparation step. Let's say we feel that our model is not performing well because of bad data, or if we feel that we are using expired data. Uh, then we can go back to the data preparation phase and remove the bad and expired data points and then follow the pipeline. We can also go back to the goal definition if we think that despite doing everything, the model is not performing and we need to rethink our task or to change certain specifications. The idea here is that we have a loop that allows us to go back to the previous steps and improve our model. Now, we may think that it seems a never ending loop, but that's not the case. Once our model achieves a threshold performance, we can deploy it. Now we can go back and improve the performance by taking a step back or two while our deployed model continues to perform its task in the production environment. Now let's have a brief summary of what we have learned. Coming back to the general picture, what we talked about is that we have started from a problem. We wrote down every aspect of the goal and the different elements that we saw. Then, following the pipeline, we had the data collection and preparation step where we collected, prepared, and cleaned the data. Then, we computed the features that we fed into the model in the model building step. We then fine tuned the hyperparameters and trained models. We chose them one at a time and evaluated the trained model on a separate unbiased dataset to have an unbiased estimate of the performance. We talked about design phase of the machine learning models, but we need to keep in mind that our job does not end once we are done with the model deployment. Once our model is deployed, we can see that from the model maintenance, we can go back to the feature engineering or to the data collection and preparation step to continue the loop, and there can be many reasons to do so. One scenario can be to monitor performance. Let's say that the data set that we gathered will be different from the one that will be fed to the trained model once it is deployed. For example, in case of image classification, maybe in our dataset we only had high resolution images that were taken professionally, but maybe the end user will try to use the model with the photos that he or she has taken from his or her phone in low light of the image can be blurry, and that doesn't match the same quality and properties that we trained and tested our model on. The idea here is that it's really important to continue to monitor our performance once it is deployed. We should be able to learn if there are any problems and if we need to do some model maintenance and then go back to the designing phase to train our new machine learning model. Although machine learning projects are similar to software engineering projects and follow a similar life cycle, but one of the major differences is that in case of a software failure, the application may crash in worst case scenarios, and we have bug reports indicating that it failed. But for machine learning, the model depreciates the performance gradually and silently, regardless of the reason. So, if we do not deploy our new updated models actively, then the model monitoring to check regularly the level of performance becomes a necessity. Now let's see few references that can be helpful. The first one is a Wikipedia link of dataset list. It can be useful if we are wondering what are the different types of tasks and the available datasets related to the task that can be experimented on. The second one is the link to the documentation of scikit-learn, which is the main Python library of classical machine learning for us to start on. The third one is the link to a cheat sheet of scikit-learn, just to go through some basic but important content which can serve as a quick refresher if we do not have the time to again go through the entire documentation of scikit-learn. The fourth one is the link to the 100 pages machine learning book from the authors who wrote the famous machine learning engineering book. It will provide a concise view of different aspects of machine learning. Now, some honorable mentions. A big shout out to the references listed here. The first one is the famous machine learning engineering book. Quite a lot of content of these lectures have been taken from this book, and worldwide it is considered a really good book for machine learning. The second one is Machine Learning, a Probabilistic Perspective, which is also a good reference book if we require to go in details of specific machine learning topics. The third and the fourth, both are scientific articles. Statistical learning theory, model concepts and results. And the fourth one is tidy data. If we require more information in the specifics of the content here, or if more examples are required, both of these articles are excellent source of information. Last but not the least, I sincerely thank you for following these lectures. Please feel free to reach out to me via direct messaging or email or comment, whichever is the most convenient to you. The more you ask, the more we will learn mutually. In the end, I wish you the best. Thank you for listening and have a good day ahead.